Hello everyone. Today we are going to look at how to generate, simulate and visualize UVM test bench for Verilator. So here the Verilator UVM bash script, what it does is it just install the required parameters and it will generate test bench makefile which is Verilator compatible using RTL to UVM workflow, and it will start the simulation. Okay, so first we need to go to this link. So I will just share this link in the description. So I have added the explanation for in the README. So basically, what it does is it just create a virtual Python environment, and it installs required Python packages. It installs Verilator, and it will clone RTL to UVM repository. And with the help of RTL to UVM repository, it will generate UVM test bench and makefile for Verilator. So here, this RTL to UVM has a sample DUT, so this basic adder. So it will generate UVM test bench based on the DUT, and it will just start Verilator simulation with makefile. Okay, so we'll just this is a project structure. So the steps is I just need to git clone this repository, and we need to go to this Verilator UVM directory. So we need to change the permission for this Verilator setup.sh script, and we need to run the script. Okay. So once it runs, these are the repositories. These are the folders which it will create. So it will create a virtual Python virtual environment, and it will git clone the RTL to UVM repository. So this RTL to UVM has sample DUT and RTL to UVM Python script, so which will take this RTL as an input, and it will generate test bench which is Verilator compatible. It will generate makefile, remaining stuff. Okay. So we'll just go through the script. So first up, as I said, it will create virtual environment, and it will activate the virtual environment. It will install the Verilator it will install latest Verilator. Okay, and it will clone the RTL to UVM repository, and it will install the required packages for RTL to UVM repository. Once it does, it will move to RTL to UVM, and it will generate UVM test bench which is compatible with Verilator. So this is a command to run this one. So here what it does is we are just calling the script with -t is DUT we need to pass. So here we are passing sample DUT.sp, which is basic adder, and in mode we will pass Verilator. So we can also use EDA playground. So here our goal is to generate and simulate UVM Verilator compatible UVM test bench. So we are given -m as a Verilator. So once the test bench is generated, so we just move into this sample DUT Verilator. Sample DUT is nothing but this design name. So if your design name is FIFO.sp, it will create FIFO directory. So it will go to directory, and it will just run make call. So once it does, you can see how much time it took, and you must be able to see this Verilator UVM to run successfully. Okay, so this Verilator to UVM uses RTL to UVM repository. This is the one. So this is RTL to UVM. So basically, how it works is we will take RTL as an input, and we use PySlang, which is a test bench linter. So we use PySlang to extract input, output ports, and parameter details using PySlang. And based on the mode, it will generate test benches. Currently we have EDA playground Verilator. So in future, I'm planning to add Vivado test bench too. So here we need to pass mode as EDA playground or Verilator. So based on the switch, it will generate the test bench which is compatible. And there is additional option. We can use -LLM switch, which will generate driver and monitor it based on using generative AI. It will generate UVM driver and UVM monitor for RTL. So currently we have a dummy UVM driver and UVM monitor. If you want to use LLM, you can use minus LLM switch. Okay, so once you run the RTL to UVM, you will get this image. So which basically explains generated UVM testbench structure. Okay, so this the script. So the script is, I think, around 1,000 lines. So it's so this is around 1,300 lines. So if you find it difficult to understand the script, you can just go to the URL link and you can just select GitHub and you can replace with dbkey. So dbkey.com and path to our just go to the repository, right? So you can just replace GitHub with deepwiki.com. So what it does is it will explain the overview of the repository. So it's LLM, so it will read your repository and it will generate an overall picture and it will explain everything. So I just replaced github.com with deepwiki. So it will just create an overview of RTL to UVM. So here it will be pretty much easy to digest what's in the repository without actually going through the code. Okay, so I just change this and you can see the index what it has generated. So I will just quickly go through what it has generated. So this is a core component like this RTL to UVM uses PySlang parser. It will generate the UVM test bench. We can call LLM and output will be based on Verilator or EDA playground mode. It will generate test bench trajectory and makefile. Okay, I can just go through this, and these are the files which are generated from RTL to UVM. So this is the overall process it does. So RTL to UVM script, it has, so if you run the script with minus LLM switch, it will call, it will use Gemini API to generate a driver and monitor or scoreboard logic. Okay, so this is so we use Gemini API. So you need to have key API key to run in your local environment. So you can generate using AI Studio. You can request for free API key. Okay, so it will send a request and it will generate driver monitor scoreboard logic, and it will just override with the default template. This is like overall flow with LLM enabled. So this is a system integration architecture. So this is how it works. So these are the external tools which we are using inside RTL to UVM. So we use PySlang, which is a test bench litter. We use Gemini API for LLM capabilities, and PyGraph is to visualize the test bench, which we saw before. And tablet is just print a result in a tablet format. Okay, so these are the input, and we give RTL as an input, and it will generate test bench, makefile, and PNG file, which visualizes the test bench. So these are the targeted platforms, EDA Playground and Verilator. So if you want to understand more on RTL to UVM, you can just replace GitHub with dbkey.com. So it has everything. So we can go to this index and see how this pipeline works. What it will be easy to generate. Okay. So now let's go to here. I will just copy. Okay. So I'll just clone the repository. Okay. So we have license readme and bash script. So just change permission so that we can execute. You can see it turn green. Yeah. So just do it like this. So as we explained, it will generate, first it will create a Python virtual environment. It will install Verilator and all necessary packages. And it will git clone RT to UVM required Python packages. So it installed Verilator and it's cloning RT to UVM. So it has cloned UVM and it's installed in Python dependency for RT to UVM. So yeah, it has installed all required packages. So now it's running RTL to UVM. Okay, so it has taken a sample dut.svs RTL. So based on this, it has generated sample dut related testbench. So we can see these are the ports, and it has generated a UVM testbench and a graph, image to visualize. So it has created test bench in 0.4 seconds. So now it started to run Verilator. So you can see this command. It started to run. So it will take around 20 minutes to complete. So we can see. So in the meantime, we can see what it has generated. So it has git cloned RTL to UVM repository. Okay. So here sample.dut sv is the RTL file. Okay. So you can see it's a basic simple adder. It's taken from VLSI Verif. Okay. So this is taken as input and it has generated a UVM test bench for Verilator. Okay. How it does is it uses PySlang, which is a test bench linter. So it will extract this input and output details and parameter details if it has. It will generate a test bench. Let's quickly go through what it has generated. Okay. Okay. So it has generated makefile and testbench. We will just quickly go through the makefile. So makefile has UVM root. So UVM root, how it does is like, so UVM root has Verilator-compatible UVM library, which is taken from chip lines. So it will point this repo to the UVM Verilator and set as a UVM root. It will add defines directories, switches we need to run. Okay. It also generate dump. Okay. So if you want to view GTK view, you can use view VCD. Okay. So this is makefile it has generated. Now we can go into the test bench. So let's see what's image it has generated. Okay. So yeah. So basically it replaces RTL module name with this one. So our RTL module name is sample DUT. So it has created sample DUT TB graph.png. So this is a top test env agent and analysis port, TLM port connections is the export, so analysis port. Okay, so this is the interface and this is a DUT. So it will generate a test bench based on your DUT. So basically it has, if you go to look at the sequence item, right? So basically it uses input. We can see this I19, I2 as an input and reset as an input, and output is a bit. So basically it will generate this template by default, and we can have input string, convert to input string, and output string to display the output. So it will create dummy generator, scoreboard, and sequence item. So you can see the interface what it has created. So this interface, it is created based on the RTL DUT input. So we use PySlang to extract the input and output details. So it will generate automatically. So if you see sequencer, so far in case of Verilator-compatible testbench, right? So one of the thing is, so we need to pass both the request and response in a UVM sequencer. So in case of, suppose in case of EDA playground, so we don't need to pass both the request and response. We can just pass one thing. So in Verilator, we need to pass both this thing. This is one of the hack we need to do to make UVM testbench to run with the Verilator library. So this is pretty much everything. So it's generated, and this is a top TB top which it has generated. Okay, so it will just include the macro, generate a clock, instantiate, dump, test. Okay. So this everything will be generated based on the RTL file. So if you want to experiment with the different RTL file, so you can change the. You can replace the sample dut.sv into your RTL file, so and you can use this. So you can replace sample dut.sv with your RTL file, and you can experiment with RTL.UVM. So this is how it will work. So, and it will take 20 minutes to run. So I have written a blog on about this one, so you can see it in a Substack. I will add description. I will add this link in the description. So yeah, if you have explained everything, I think so. Output basically it will look like this. So once it does it, actually it's take around 20 minutes to run this Verilator simulation. So once it completes, you will see the log, UVM logs, everything with Verilator, and you will receive this Verilator plus UVM ran successfully. Very soon you get to know it has completed. So we have, so please give it a try and let me know. And we have Discord community too. So if you want, you can join there. Okay. And that's it from my side. Thanks for watching.